anything down here. Are we, All right. Well, good afternoon, everyone, and welcome to Philips and day 2 of HIMSS 2017. We are very glad to have you here with us. We've got a great presentation for you, just about to kick off, and in fact, it's just one of the many presentations we have right here in the forum throughout the week. We do a different topic and a different speaker every hour on the hour, so if you'd like to grab a schedule to see what's coming up for the rest of the day, and tomorrow we encourage you to grab one from the desk over there before you go, and again, something interesting and varied at the top of the hour. We've tried to do it a little bit differently this year, and instead of just doing kind of the same presentation, we're really bringing in a lot of senior Philips executives. We're bringing in a lot of outside executives and top people in the healthcare industry, from hospital systems, our customers, our clients, some patient advocates. So it really is quite a varied lineup, and I think you'll definitely find something of interest. We've got a very good one for you here, just as soon as this wraps up here. And make sure I have my clicker here. So that's basically it. We also have a job fair going on, which I'll tell you about at the end. So if you're looking for maybe a new opportunity, Philips would like to talk to you about that too. So once again, welcome to the Philips Connected Health Forum. As I said, we're going to have exciting speakers throughout the week here on topics like population health, care coordination, and personal health, to advanced analytics and clinical informatics. All of them start at the top of every hour, as I said. Grab a schedule, and you can see what all of those are. So for the next session, precision medicine in oncology as a real-time healthcare platform, or needs a real-time healthcare platform, I should say. We're very pleased to have Li-Chen Xu, Vice President of Enterprise Informatics at Illumina. She's and her team are focusing on solutions to help clinical researchers to interpret genomic data with ease. And Li-Chen has extensive genomic experience in sequencing technologies and clinical applications as well, and she's passionate about clinical applications using genomic solutions. Joining her today is Louis Coulat, who's the General Manager of Genomics of Healthcare IT here at Philips. Louis and his team are applying genomics across health spaces to better understand patient populations, treatments, and costs, and they're working with leading medical centers to create the largest patient-based data sets to transform cancer care. So they're going to be discussing how Illumina and Philips are leveraging shared information across disciplines to improve precision programs in oncology, and we're very pleased to have both of them with us. So please help me welcome Li-Chen Xu and Louis Coulat. Thanks.
Thank you. I think you had it right. It has a real-time healthcare platform. So that's great. No, thanks. And really thank you all for joining us today. And with this partner presentation, we're really pleased with our guest, Illumina. You know the Health Suite story about how Philips is using Health Suite to bring data from across the continuity of care, from healthy living to diagnosis, treatment, together in order to better understand what's happening in our populations and lead to better treatments and outcomes. Along these lines, we need to have data, from across these different places. And Health Suite's an open platform. We've strategically partnered with Illumina on the genomics side. You probably don't know, maybe some of you do know much about Illumina, but I learned something new. I learned 80 to 90% of the genetic information that's produced is produced on Illumina sequencers. So Illumina has really been the company that's in many ways defined the field of genomics for us. So really pleased to have us here today, and really pleased to have a chat with my friend Li-Chen. So
thank you for inviting us.
Okay, so I just wanted to start with just a little level setting, in terms of precision medicine and what we mean by it. And if you look at the National Institutes of Health website, they have a really nice way of describing it. They talk about precision medicine is all about understanding what makes us different from each other. It's all about variations in our behaviors, our environment, and our genes. And when I think about genetics and genomics, and I'm an older guy, and used to be that genetics was all about family history. And that's how we did genetics. And that's how we still genetics. It's kind of, I think, the old way, but we still do this. We look at family histories, and they're really informative. Now, the first genome was sequenced at a cost of several $1 billion. I think that was 2003?
Yeah, 2003, about $3 billion.
$3 billion for one genome. And companies like Illumina, well, I say the company Illumina, has really driven the cost down to where you can now do an entire genome for about $1,000. And I understand that's even getting lower. So we're getting to the point where we can now afford to acquire this data on a per patient basis and really start using it to understand, again, how do genes now influence how we're different from each other. So let's start with next generation sequencing. So why don't you help us? What is it and how's it different from the molecular diagnostics that we all know?
Yeah, so molecular diagnostic has been in the clinical world for quite some time. Now, there are obviously, you guys probably are familiar with the traditional molecular diagnostic in the field as a qPCR or Sanger sequencing methodology. Now, the next generation sequencing is a very fast parallel sequencing technology that can cover large target in the diagnostic world very rapidly. So there are a couple of unique features or unique advantage in the next generation sequencing technology. The first of all is the sample. So the sample normally in a lot of situations, for instance, one typical example in the infectious disease, you have a mixed population of pathogen, and in traditional molecular diagnostic or serological diagnostic, you need to culture and you need to wait for the isolation of a particular pathogen, then test. NextGen doesn't have this restrictions. So you can start with a mixed population of pathogen, you can detect immediately in the same test. Now, the second feature of the advantage in this diagnostic world using NextGen is it can really target a large section of the genome, very often actually whole genome in the low complexity organism or even human, the entire genome diagnostic. So basically, you don't really have to segment your DNA into many separate tests in traditional method. You just do the shotgun all at once. Now the power is behind the informatics. Now the informatics made that possible. Basically, it's a big puzzle of a DNA sequencing, then you put it back into the genome scale. So that's really the revolutionary technology in the market. The third one is the cost and turnaround time. So the cost represented in, if you traditionally have to spend a month or several months, the cost on the human resource is huge. Now, the secondly, also when you chop the genome into very small individual tests, the cost is just rocketed to a very high scale. So that's why in the traditional method was several $1 billion, then dropped to $1 million, and now it's $1,000. So that's really speaks to the advantage of the technology. Mm-hmm. And I think particularly for cancer, today's topic of cancer, there's another advantage because earlier I talked about the pathogen population where you can have a mixed, now in the cancer world, it is a mixed population because none of the cancer genome is identical to each other. So you will have the mixed DNA population in the diagnostic, and the NextGen has a unique advantage to have a very high resolution to detect the causing mutation in the DNA.
Mm-hmm. That's great, thank you for that. When we think about, you said earlier that with next generation sequencing, we can now sequence hundreds or thousands of parts of the genome at once. If I'm a cancer patient and I have a test, how does that help my clinician?
Yeah, so that's actually a very common question. I was in the next generation sequencing for many years. At the very beginning of the history, we got a lot of questions. So you tell me the genome sequence, what do I do with it? It could be no drug or whatever. So in the past 10 years or so, actually the field already progressed quite a bit. So there are a couple of benefits. One is in the field that when you know the predisposition in your genome, you can actually proactively provide health management as well as lifestyle choice. One typical example is breast cancer. So in certain population, the high occurrence of breast cancer is due to the genetic background in the family. So if you test early in the healthy population, you can proactively manage your lifestyle choice. And so that's one concrete. Now the second example is actually in the family planning. A lot of couple, they could actually do a lot of genetic tests for the future child or actually existing child to manage their expected challenge in their life if there is a inherited issue. So those are a very apparent advantage using the next generation sequencing. And then ultimately, if there is a disease already in our life we have to handle, you could use the next generation technology to provide the guidance in the therapy choice. And the therapy choice could be very much very precision to the individual base. So that's why we call it personalized medicine. So those examples, I'd like to pick a couple of simple examples that in the for instance, in the colorectal cancer, if you have a Lynch syndrome in the family, and then the doctor could actually proactively manage the family, and also in the therapy choice, they also can predict in which side of the colorectal the cancer will mostly occur. So that actually changed the course of diagnosis and also the treatment. So those are very, very dear to our daily life in a lot of situations.
Yeah, and I know I've seen some studies, and no one's really fully quantified it, but every study I see that comes out that looks at, next generation sequencing on cancer, they find somewhere between 10 to 15% of the people are harboring some genetic predisposition.
Correct.
And they find it in their tumor markers. So you think about a population, and suddenly you know that even if I get diagnosed and maybe I'm late stage, they could do what they could do for me, but then maybe my brother or sister could get tested or screened preemptively and maybe catch it earlier and have surgery and have a much lower cost. So my test can actually 10 to 15% at a time multiplied by whatever the inheritance is could actually help somebody else.
Exactly.
And have economic benefit.
Exactly.
That's great. So I love the amount of data we get from this, and I know the interpretation is always hard, right? So we know the amount of literature that's published in cancer research. If you've ever been to an AACR cancer research meeting, there are tens of thousands of researchers there. They publish constantly. We also partner with a company called N of One that does literature curation and interpretation of these cases and automate it. How much do you think the ability to automate and rapidly interpret these things is going to impact the adoption of these technologies? Because at least I hear from some customers at the, say, community hospital level or so forth that they feel the barrier is too high. They can get the technology, but then they've got to do all this analytics and interpretation. So wanted to just get some of your thoughts on that.
Yeah, so the impact will be huge. I think that's actually the main bottleneck right now. And I see a lot of companies, of course, N of One is one of many of the technologies that people are trying to tackle this problem. So we work with a lot of customers in the clinical setting. They basically tell us, your sequencing obviously is very fast now. In the past several months, now it's only a few days. Now the bottleneck is afterwards. So the afterwards is how do you interpret the variant? Even you discover a certain variant that's unique for a patient, how do you interpret? So here there are a lot of methodology that people are developing, and we are actually certainly in partnership with Philips is one of them. So the interpretation that can rely on the literature in the scientific world, this mutation might be already discovered in some population of hospital research, and so you can reference to that. Or you can also use a lot of deep learning algorithm that people are developing. It's a buzzword. So it's really a lot of technology advancing very rapidly. So you can kind of doing a lot of machine learning to take advantage of the existing data, then feed into a lot of brain power of the computing. And that's also where this field is moving very rapidly.
Yeah, I think so. Yeah, no, that was great. And the, we have this mission at Philips. It's on our website. It says we want to improve the lives of 3 billion people by 2025. And so, so how do you think? I'm a big believer in genomics. It's what I do. So I think this could have a huge impact. We talked about cost and we've talked about analytics. Let's assume those problems get solved. What other barriers do you think remain to getting this really broadly adopted out in the community, used, whether it's in cancer diagnosis and prevention, in rare disease? I mean, how do you see this? This is
so I think, currently there are certain barriers. One is actually, in my view, is the connectivity. So our daily life already moved to tremendous connectivity, and everybody has a cell phone. You can't live without your cell phone, almost holding every day. But in the medical world, we're not there. So that's really connectivity prevents a very rapid diagnosis as well as the treatment choice that you can leverage the community knowledge. So I think the connectivity is a big part of it. And I was very impressed by Philips' solution that you showed me earlier on the health suite. So those things can be the sophisticated information infrastructure behind the scene to really connect the medical world with the consumer world as well as the medical professional world. The second one is, I think, education, that you really get through this education in the professional world as well as the consumer, or you call the patient. I kind of would like to call them just the general public, where before they become a patient, we should really work with them.
They're healthy
in the
right now.
Healthy
people.
Right, healthy people. So really get ahead of the curve in the healthcare system. So I think two areas, connectivity from a technology perspective, and then education of the general public in the medical world. Yeah. So what's from a Philips point of view, what's your perspective on that?
Yeah, so the way I think about it, and being at Philips, it's often I'm a genomics person talking to the non-genomics people, or then I'm the non-genomics person talking to genomics audiences. And I'm really thrilled with the progress we've been able to make. You talked about healthy populations and being able to screen and maybe disease intercept, right, before people actually transition to become sick. What is it we can do? And there are some studies around cardiovascular that people have looked at now. We talked about rare disease and also cancer prevention, right? So that's really encouraging to me. But the other thing is, I know there are things that we don't yet understand. The genomics are not giving us the full picture. When gene sequencing was first tried in a clinical setting, people said, yeah, we'll just target the mutation. And we knew very early on that, well, no, you needed more than that. You needed to know the disease indication at least, and maybe some other data. We know we've identified resistance mechanisms. So we know that there are some drugs, in cancer particularly, that if you've got this resistance variant, you won't respond to a therapy. So the economics are immediately apparent. But yet we also know there's huge people that don't respond to the therapies when we think the genomics seem to match them up right. So where I see this going, or where I think it's going to go, is to start bringing back this phenotype data, this clinical data, the clinical context, or past medical history. Maybe if you have a patient who has MS, and they've been on immunosuppressants, maybe they won't respond the same way to an immunotherapy, a checkpoint inhibitor, as somebody who isn't. And I think starting to build some of that evidence together is going to lead, I think that's, at least in cancer, is going to lead to the next kind of milestone.
I think that takes a lot of alliances in the industry to really build that momentum. And the demand is so high. We see a lot of requests from our collaborators, customers, and I think definitely it's a big focus.
So just as a maybe last question or final question, the thing I also like about genomics is if you think next generation sequencing is like bleeding edge, it has its own bleeding edge.
Right.
And the bleeding edge of next generation, this is not a pun, it's liquid biopsy. So using blood tests to screen for non-invasive prenatal testing and cancer diagnosis screening. So why don't you share some thoughts around that and what Illumina is doing in that field? I think it's super exciting, and maybe we'll see it in a few years down the road in real practice.
So the liquid biopsy is a new field that really, it's actually a buzzword too. Every company is working on that. We actually have a spin-off company called Grail, entirely focusing on that. But in this field, actually, there are two areas, or three areas, you could say, that it's used in prenatal, those kind of tests using the circulated the DNA that from the fetus to test the fetus before it's born, so you can predict a certain genetic disease. Now the second is also very much in the cancer. So the cancer, there are two aspects. So you could actually, if the ctDNA test is very accurate, and we're not completely there in the field, but we're getting there. It can become a very much a predictive tool for people to understand if you early stage or even years before the onset of the cancer, so people can do something about it. Now the second thing is actually after the treatment. So as I mentioned earlier, that the cancer cell is very much a mixed population. You always have certain bad guy, very, very low percentage in the population, and you treat them, you may kill majority, but you have maybe 1 in a million, it didn't disappear, and you still have a problem to detect it in that stage, and it will come back. So this actually speaks to a lot of situation in the oncology field. How do you really treat the patient with those situations? So those are called a minimal residual disease that next generation can really tackle to detect those minor variant in the genetic population of the blood. So the cell-free DNA is a technology really non-invasive and also early onset detection. And one application in particularly particular for the elderly, you don't want to really do a gigantic operation, but if you do a very precise diagnostic, and it's a life quality change for everybody in this field. So I think it's the next thing in our field. I think everybody is really trying to see what's the huge application for this type of test.
That's wonderful.
Yeah.
So great. So yes, I wanted to thank you for being our guest here today. Really enjoyed chatting with you, and look forward to what we're going to do together.
Thank you. It's a great partnership, and we look forward to more collaboration in all the different aspects of the healthcare. Thank you.
All right. Thank you very much. We appreciate you all being here, and have a great day. Thanks again for your time. Did you guys want to see if there are any questions? Did anyone have a question before we wrap things up, or we got time for one or two? We're getting close to lunch, so that might be it. Well, anyway, we're delighted to have you. Thank you for being here. And thanks to all of you as well. We're going to go ahead and get underway again at noon here in the Philips booth. And our next topic is another great one. We have another discussion talking about healthcare, specifically from a doctor's perspective this time. And it's Dr. Elliot Siegel. You may have heard of him, but he's going to be talking about artificial intelligence, and this will be a very, very cool topic. So please come back. That'll happen right at noon today. Thank you. If you'd like to find out more about the Philips team and see how you can be a part of it, we are actually looking to talk to people this week about that very subject. We have a career fair over at the Hyatt today. If you want to check that out, it's CF23, and then Dominic and Justin, our HR guys, are over there now, but they'll be back tomorrow. Thank you.